and welcome to our session on how accelerating your data infrastructure can help you move more quickly into the future of banking. I'm Ron Raffensperger, and I'm a Senior Solution Director here at Huawei in Shenzhen, China. So what is it that is accelerating the changes within banking? First is that our customers' behavior is changing, and it's changing because of two things. One is more and more their life revolves around their mobile device. Whether it's using Grab to call a car, or Uber Eats to get something to eat, or using their social networking. Everything revolves around that. The other thing that is really having an impact, and very quickly, is that we're entering a period of what we call the new normal. This is the post-pandemic, where people had to really rely on their mobile devices for all of the things in their life. What that's caused is a change, and it's a change that the users want everything to revolve around them, and that's where our big challenge is in the banking industry. So it has to be whatever device I happen to be carrying, whenever I want to be able to do this, and the user interface has to be customized for me. It has to do the things that I want it to do. So what are some of the challenges that this evolution is causing in the financial services industry? The real challenge is to balance your traditional banking with the new banking. And that means that you need to be able to handle things like increasing your transaction rates by a factor of 10, by being able to reduce the costs of acquiring new customers by a factor of 10, and also being able to meet the challenge that is presented by your customers expecting constantly that they will have a new experience by being able to go from new software being available every few weeks or even months down to being available within days or a week. So how can Huawei's data infrastructure help in accelerating your evolution in your industry? It revolves around three primary points. One is around being able to use intelligence for managing, being able to have not only safe and secure, but rock solid kinds of performance and very high performance at that. And finally, being able to scale, being able to have very low cost, very high volume storage. And so what you want is you want to be able to create a storage pool that is then fed from all of your applications, whether it's your traditional bank applications, traditional warehousing, or new kinds of AI accelerated learning that make it easy for you to compete in the future. So now let's look at each of those three characteristics, beginning with intelligent management. So Huawei has created a management platform that helps you not only to manage the overall system, but take care of a lot of the tasks that you had to do manually before. An example is for planning, where previously you had to spend a lot of time figuring out what data you wanted in which tier and how often that should be reorganized. With Huawei's intelligent management system, we can automatically do that for you. So the process goes from being very long to just happening within a day or so. The second is in actually how you allocate that storage space. So previously, you had to do lots of statistics. You had to then do estimates of what you thought futures were going to happen and be able to then arrange the storage for the different applications in your different kind of storage. But with our intelligent management system, we can automate that process for you. And the third area is actually running the system, the operations and the maintenance. And as you add more kinds of intelligent storage systems, it becomes much more difficult to be able to actually manage them. It takes a lot of manpower, takes a lot of time. Actual troubleshooting can be a real problem. So with our intelligent management system, we can give you all of the statistics that you need, and we can actually do projections of what you're going to need going forward into the future. We can be able to spot problems as they occur before they cause problems, and then we can react to those problems even after they have happened much more rapidly. So your troubleshooting time goes way down. Your reliability, of course, your availability actually goes up substantially. And we've also built into this system a capability that is pretty unique, and that is we understand that in order to be able to have the fast life cycle of product development that you need to be able to compete in the future, you need to be able to have the continuous integration, continuous development, and to do that, you need to have copies of your actual data so your development and test people can work on real systems as they're figuring out whether or not the new software is ready for deployment. Our intelligent management system can make copies within seconds so that your development and test people are always up to date, and you'll get much faster rollout of new kinds of software. The next area, we talked about performance, we talked about reliability. We use the terms fast and solid because it's easy to imagine. So the key to that is our Ocean Store Dorado all-flash storage system. This is really an impressive system. It has performance up to as much as 20 million IOPS. So no matter what kind of a load you have, it'll be able to be handled very easily without this. And from a reliability standpoint, we can actually have up to 7 of an 8 controller set of enclosures fail without any loss of the system as a whole. So whether or not you're doing normal kinds of business analysis, whether it's for your core banking, whether it's for data warehousing, or the kinds of regulatory reports that you need, all of these kinds of applications can be accelerated and become much more stable, much more high performance as a result of using Huawei's Ocean Store. So how do we do this, particularly around the performance? What is the key? So the key to that performance is what we call FlashLink technology. FlashLink is an end-to-end solution that we have created to be able to ensure that you always have stable performance. And it begins with how do you connect the storage systems to the applications, the servers that are running those applications. Well, we were a pioneer in using NVMe, which is an IP-based communications protocol. We use what's called remote DMA over a fabric to be able to provide this connection. And it goes from the servers through the network to our controllers, and from our controllers through to the actual storage disks themselves. This gives us a great advantage on latency, reducing it by up to 30%. And it also provides an end-to-end reliability. The second piece is our operating system. So within our disk controller itself, the storage controller, we have used a specialized version of an operating system that knows about what the computer is capable of. So it actually takes tasks, breaks them up, puts them in different parts of the computer to guarantee that you will always have this consistent throughput. The third piece is around being able to have the storage systems themselves. So Huawei makes our own controller chips that have our own algorithms inside of them, and they're on each of the storage disks. And they provide a number of capabilities, but 2 of them that we highlight are called wear leveling and anti-wear leveling. And just suffice it to say that between these 2 capabilities, they give you over 2 million hours MTBF, so very high reliability, very long life. And the final area is that we have now included one of Huawei's AI chips in our system. And what that chip does is it looks at your actual usage. So previously, you had to do a lot of guesswork to figure out what were the cache settings that you wanted to use to be able to optimize the performance. Well, using our AI chips, we can actually look at your real performance, look at the real activity that's coming out of your applications, and adjust the cache automatically. And this can give you a greater cache hit rate, which translates directly through to higher performance. So I know there may be a few skeptics out there in the audience. So what we're going to do now is we're going to go to Huawei's Chengdu Interoperability Lab. This is the largest interoperability lab in China, in Asia actually, and we have one of our engineers, Mr. Zhou Hui, standing by, and he's actually going to demonstrate putting a Huawei Ocean Store Dorado system under stress, and you can actually see what the performance is, how many IOPS, and the latency that exists within this system. Mr. Zhou, take it away.
Hello ladies and gentlemen, my name is Zhou Hui, Senior Engineer of Huawei Data Storage Product Line. Now I'm in one of our storage labs. This is the test environment I'm going to show you today. The product for testing is a new generation Ocean Store Dorado 18000 system. It is connected to two servers using two fiber channel switches for network redundancy. Two servers are configured with two dual-port 16 gigabit per second fiber channel HBAs. Ocean Store Dorado system is configured with 8 controllers, 12 4-port 32 gigabit per second fiber channel front and input-output modules. RDMA high-speed links are used to connect the controllers to two SSD enclosures. The enclosures have 70 NVMe SSDs, each providing 3.84 terabyte capacity. On the test host, VidiBench is running in a Red Hat 7.2 operating system. Let's log into the test host and use VidiBench as the test tool to set the test model. I/O size is 8 kilobytes, read-write ratio is 7 versus 3 random, simulating OLTP service. Then we start a performance test script. Let's come to Device Manager to check out the performance. Instant performance doesn't mean anything, so let the system be running for 30 minutes. Now we can see the latency remains stable at 80 microseconds in the past 30 minutes. Yes, Ocean Store Dorado made it. 81 microseconds. Wow! I remember the industry average is 500 microseconds. Ocean Store Dorado supports minimum 81 microseconds, which is 5 times better. With this performance, Ocean Store Dorado can meet the demands of performance in production and transaction scenarios. Then what about the performance after enabling software features like Snapshot? Will the performance drop down? As data volumes are increasing at a faster pace, enterprises must consider how to shorten the backup window. To address this issue, Ocean Store Dorado all-flash storage uses HyperCDP to provide continuous, most frequent data protection with zero performance loss. We use the same test topology and map 2500 gigabyte plans to the host. Let's first log into the test host and use the VidiBench test tool that uses the model of 8 kilobytes 7 versus 3 random reads and writes to simulate OLTP services. We then start the prepared performance test script to keep delivering 1.1 million IOPS. The device manager shows the system performance is around 1.1 million IOPS. We create a HyperCDP task to protect 20 LANs in the group. Set the policy to create a snapshot every 3 seconds. Now start the task. We will see each LAN is creating a snapshot every 3 seconds. Go to the performance monitoring page. It shows the performance is stable at 1.1 million IOPS with no jitter.
So that should convince everyone of our performance and our latency. But now what about reliability? One of the key characteristics of our Huawei Oceans Dorado system is it's rock solid. And that comes from a number of characteristics. I mentioned the wear leveling and anti-wear leveling of our disks, but it also comes from our design of our controller system. So our system can go up to 32 controllers, but the basic unit usually is 8 controllers. And if you have that, which is 2 enclosures of 4 controllers each, you can actually lose up to 7 of those and still not lose access to your systems or any of your data, because all of the controllers are interconnected to all of the storage devices as well as each other, so the caches are all consistent across them. The second is on the connection between your servers, which are running your applications, and the controllers themselves. And here we have pathing software, everybody does, but with Huawei system, you can actually lose all but one of those links and still have complete functionality, so with no loss of performance. And part of that is a result of the NVMe, but part of it is that what we have done in our software to be able to support that. And the last area is on the reliability. So traditionally with storage systems, in the older days, we had actual RAID controllers that you would program, and they would control the disk distribution. And when you had a disk failure, then you had to put in new disk. It could take hours and hours to be able to rebuild that before you had true reliability again. Over time, most of us have moved to software-based storage, RAID control. But what we have done now is we've created a new kind of error-correcting algorithm that we call RAID TP. And this actually allows you to lose up to 3 disks, which is unheard of. Other systems, whether it's RAID 6, RAID 5, you can lose 2, but after that, you've got a lot of problems. With ours, you can lose up to 3. So depending on how we compare with a RAID 5 or RAID 6, we can get up to, theoretically, 1,000 times higher reliability as a result of this RAID TP algorithm. And because I really like to demonstrate this sort of thing when people come to visit our exhibition hall in Shenzhen, I always like to be able to go to our storage systems, pull out controllers, and show that nothing happens as a result of that. Everything continues to operate. Well, I'm not in our exhibition hall, and I'm not that great probably at showing it. So we're going to go back to Mr. Joe and have him show what happens when you actually do lose 7 out of your 8 controllers. Mr. Joe?
Welcome back. First, let's check the status of Oceans to Dorado 18000 from the device management software Device Manager. The 8 controllers are located in 2 controller enclosures. Now they are all running stable. Let's log into the test host using VDBench at the test tool to set the test model. I/O size is 8 kilobytes, read-write ratio is 7 versus 3 random, simulating OLTP service. We will then start the test script to keep delivering 1.1 million IOPS at 0.5 milliseconds to 8 controllers. Now VDBench is showing the running status. We can see the performance of 8 controllers remain at about 1.1 million IOPS in total. Let's come to the Device Manager, which shows the same performance of 8 controllers at 1.1 IOPS. Each of the 8 controllers is around 140,000 IOPS. The 8 controllers are 100% in load balancing mode. Now I'm going to cut down the power of one controller enclosure to simulate the failure of 4 controllers at the same time. From the Device Manager, we can see the controller enclosure 1 is faulty. 4 controllers are offline now. The rest 4 controllers continue to provide services. The performance drops to about 550,000 IOPS. load balanced on the 4 remaining controllers. Let's remove 3 out of 4 remaining controllers one by one and see what happens. Now controller enclosure 1 and 3 controllers from controller enclosure 0 are all offline. Only one controller is running. From the performance table, we can tell that the system is still running after we put 7 controllers offline on the remaining 1 controller. Now I will put all the controllers back to online mode to recover from the test scenario. Okay, the system is recovered and ready for the next test.
So, I hope you're now convinced. So this answers the question of what happens if you lose equipment within one data center. But certainly for financial institutions, being always available is of critical importance, not only to your customers, but to your regulators. And so Huawei has a solution we call Hypermetro. It allows you to have 2 data centers distributed by up to around 100 kilometers who are running in an active mode. So both data centers are running at the same time. The load from your customers and your internal applications is spread evenly between them. But if you were to lose one of those data centers, the other would continue to operate with no interruption. So your RPO, your RTO, both of them are 0. In addition, we have created the ability to have a synchronized remote site up to 300 kilometers away. That can also be synchronized. It's not running active, it's your fallback. And so even if you were to lose both of those main data centers, your backup would continue to operate. And this is really an impressive set of capabilities that ensures your business continuity. I think sometimes it's hard to visualize exactly how this active will really work in practice. And so we're going to go back to Mr. Zhou in Chengdu, and he's going to demonstrate what happens when you have 2 systems running in parallel, operating your applications, and one of them just suddenly fails. So back to you, Mr. Zhou.
Let's look at the demo environment for a gateway-free Hypermetro active-active solution. In our solution, we use 2 ocean stored radar systems, touchline servers, switches, and optical fiber to establish a gateway-free active-active solution. This solution is unique because we can guarantee reliable services even when data centers are separated by the distance of 300 kilometers. The active-active design implements load balancing and non-disruptive takeover between 2 sites. Let's log into storages in both sites and have a look at Hypermetro configuration. This is the storage in site A and this is the storage in site B. Currently, these 2 storages work normally. First, we can have a look at the remote device of each storage. 2 storages are connected through the fiber channel links. Also, we can have a look at Hypermetro domain. There is a Hypermetro domain already created and working in quorum server mode. Now let's go to the Hypermetro pair. This pair now is working normally and the 2 resource LANs are mapped to the server inside A at the same time. Let's log into the test server and check the Hypermetro LAN. The Hypermetro LAN disk name is SDM. And now we start this VDBench script to keep reading and writing Hypermetro LAN. The size of I/O is 8 kilobytes, 70% read, and we start the script to read and write Hypermetro disk. Now the VDBench tool is simulating the service on the test server. Go back to the storages. Check the storage performance, first for the storage inside A and second for the storage inside B. Inside A storage, the amount of IOPS is about 46 thousandths, and also for storage inside B, the amount of IOPS is about 46 thousandths. So we can see when the server reads and writes hypermeter LAN, the two storages in two data centers will provide service at the same time and they are load balanced. Next, we will show the non-disruptive takeover between the two sites, keep the service running, and simulate cutting off power supply of the storage in one data center. Here we choose the storage in data center A to switch off power supply. Now we switch it off. The storage inside A is inaccessible, and we go to check the service. The service keeps running, there is no interruption, because the storage in data center B has taken over all the services. Go to the storage in the site B performance monitoring page. We can see after one storage is down, another storage has taken over all the services. The business has not been interrupted. We have seen the hypermetro solution load balancing and non-disruptive takeover between the two sites. Next, we just need to wait until the storage inside A to recover. Let's keep the VD bench running, waiting for the storage in the site A. Okay, now the storage A is back. The remote transmission link between the two data centers is up. The hypermetro peer will start the incremental synchronization automatically, and after synchronization is finished, the hypermetro peer will recover to normal. During this time, the VD bench service keeps running with no interruptions. The traffic of the two storages is balanced again. That's all the test case I wanted to show you today. Thank you for your attention.
So we've been taking you through what are the highlights. We've demonstrated how things operate. Now let's look at actually a customer case. So this was a bank that took a set of systems from different manufacturers and migrated them all to the Huawei Ocean Store Dorado. And this was more than 100 applications. They have more than 18 petabytes of storage in their systems. And they went to 100% all flash, both for their production as well as their development and test systems. The results were really quite amazing. So they were able to take their report times down to only about 15 minutes, and they have not had any problems because they've been running our active systems. So they've had this gateway-free hypermetro system that's been connecting their data centers together, and their efficiency has gone up dramatically. So now we come to the third leg of our triumvirate, if you will, and that is cost-effective distributed storage. One of the things about operating a future bank is that you're going to be collecting lots and lots of data that you didn't have before, and you need to be able to cost-effectively store that. But you really don't want to create different storage silos for this information because it's wasteful. So Huawei has our Ocean Store Pacific distributed storage system. It has three primary characteristics. One is that it supports all of the different protocols that you will need, whether it's the normal kinds of file system, whether it's the object storage, HDFS storage. All of these are supported within one system. It also has great density. So we can actually put up to 120 disks in a 5U enclosure. And finally, it has just incredible survivability. You can actually distribute this data across 3 different data centers so that no matter what happens, it's always available. So now let's look at each of these individually, beginning with the multi-protocol convergence. So you, in the future, are going to have lots and lots of different kinds of information. You've got log files, you've got audio, you've got video, you've got just everything. You could have streaming, social media, all of it has to get stored. Now, traditionally, what you've had to do is store that in different systems, because maybe it was coming in using a file protocol like NFS or CIFS, or maybe it was coming in using an object protocol like S3. But afterwards, you needed to process it using some big data technologies like Hadoop. And so to do that, you needed to be able to then get it out using HDFS. So many times, people will put it into different silos and then copy it all into a storage pool that then their big data system can work on. With the Huawei Ocean Store Pacific system, we support all of those protocols, including your normal SCSI and iSCSI protocol. But for the ones that you typically use to get in and out of your data warehouse, we put all of those into one data storage. So even though I put it in with S3, I can read it out using HDFS. And so this means that you don't have to copy things across storage systems, and it gives you a much more cost-effective system, again, building on the cost-effective characteristics of our Ocean Store Pacific system. And now, looking at capacity. So typically, if I wanted to have like 108 disks, I'm going to need 3 different storage enclosures. It's going to take up a lot of rack space. One of the concerns that CIOs and IT management has is that as the amount of data that I store grows, that I'm going to have to build another data center just for storage. But with the Ocean Store Pacific, we can actually get 120 disks in a 5U enclosure. And so at 24 disks per U, that's the highest available in the industry, and you can get up to more than 2.4 petabytes of information within that capacity, because we also use a very special way of EC. So I don't want to get too far into the technical details, but essentially with some of the open source distributed storage systems like Ceph, you actually have multiple copies, maybe 1 copy for each. So your overall efficiency is only about 50%. When you have some other systems, maybe you have 3 copies that are spread apart, and so maybe you can get 67% efficiency. With the error correcting that Huawei is using in the Ocean Store Pacific system, you can actually get up to 93% of your storage actually utilized. So you're not wasting a whole bunch of storage space just simply to have backup copies in case something fails. So we've shown you how you can have very large capacity with our Ocean Store Pacific system, and how that capacity is very effectively used using our error correction. But what about the fact that now I've got lots and lots of data and it's all in one data center? What happens? How do I address the requirements of regulators and my security people to be able to spread that risk? So typically you will take and make multiple copies across up to 3 data centers. When you do that, of course, you have to replicate all of that amount of storage. Well, what Huawei has done is created a unique way to separate that storage, and rather than having complete copies in each of the 3, we distribute the copies across the other data centers, so that any 2 data centers can reconstruct all of the information that was previously stored in all 3 of those data centers. It's a very unique set of capabilities, and it saves you up to 46% compared to actually having to keep multiple copies. And it's also, of course, very fast to be able, because even if you lose that one data center, you can still online use the other 2 data centers and then rebuild the information that was in the lost data center. So really a unique set of capabilities. So let's take an example of a customer that has actually deployed the distributed storage system and see what the impact is. So this is actually China Merchants Bank. It's one of the leading banks here in China, particularly in how they've adopted technology. So they had put in a Hadoop system where they had separate clusters for their different use cases. And each of these was using a typical Hadoop environment where you have the compute and you have the storage as part of one server, and then you build up the system by putting those servers together. But that gave them very low efficiency. So the compute efficiency was down around 11%. The storage efficiency was equally low. So what we allowed them to do was to create one unified pool of all of this information that was previously in separate silos, and it can all then be accessed using the Hadoop system. So we took the storage out of the Hadoop clusters and put it in the standalone distributed storage system, and then it's accessed by the Hadoop cluster just as though it were local storage. And this dramatically increased the performance, and it also increased the efficiency of the storage system, giving them up to a 30% reduction in their TCO. So banking today is becoming ever more complex, and it's not going to get any better in the future. Not only will you have lots of your own systems, but you will be interconnecting with systems from partners across the globe, not just within your own home regions. And so you're going to have many different kinds of storage needs. And Huawei, because of the breadth of our product lines, is able to provide you that storage, whether it's storage for your big data warehouses using Hadoop, whether it's your active disaster recovery solutions, whether it's your normal kinds of storage that just needs to be accelerated by having all flash. It doesn't matter. All of these can be put together in one intelligent set of storage pools that Huawei can help you to manage over time. We have a lot of experience migrating from other companies' systems as well. And so I think that when you're looking at the complex requirements of the future bank, that Huawei really does have you covered. So now we've shown you all of the capabilities that Huawei's storage systems have, how they're very intelligent, they're able to be cost-effectively supplied, and they're very solid, and they're very, very reliable. But of course, your situation is unique to you, and you need assurance that you are not becoming a pioneer on this. And so Huawei, of course, is in more than 170 countries around the world, and our focus on financial services industries over the last few years has resulted in very substantial growth across the world. So whether it's up 50% in Latin America, doubling in the Middle East, across Europe, Asia Pacific, and of course here in China, we have seen just really incredible growth. And we look forward to being able to help you moving forward to become a future bank. So that's it for now. Thank you very much for your time, and we appreciate all of your activities in support of Huawei.